I told you the matter is pure, impure. In case of impure we study about the solution. We study about the solution. Solution are homogeneous. Solution are homogeneous mixture of two or more than two non-reactive substance. Solution is are the homogeneous mixture of two or more than two non-reactive substance. For example, sugar in water, salt in water. For example, glucose in water. This is the solution. Solution are the homogeneous mixture of two or more than two non-reactive substances. Example, I will give you the sugar in water, the salt in water, glucose in water. This solution contains mainly two components. First is solute and second is solvent. Solution contains two components. First is solute and second is solvent. Solvent, the component which present in more amount comparison to second component, and solute which present in less amount. For example, I am giving an example: sugar in water. The water is solvent and sugar is solute. Because sugar having the less quantity, if I am saying 1 tablespoon, 1 spoon sugar in 1 glass, means water present in more quantity as comparison to sugar. The sugar behave as solute and water behave as solvent. Solution contain two components, solute and solvent. Solvent is that component of solution which present in more amount, but solute present in less amount. Whenever any solution is formed, there is two components. First is solute and second is solvent. Both plays very important role in the formation of a solution. You are thinking like what important role? First, solution formed by solvent and solute. In a solution, solvent present in maximum amount and solute present in minimum amount. Solvent always tell us about state of solution. For example, sugar in water. Water is liquid. Whenever we mix sugar in water, the solution having state liquid. Again, I am explaining this. The solvent which present in solution tell us about the state of solution. State of solution means whenever sugar is added to water is liquid in state. Whenever sugar dissolving water, the state of solution becomes liquid. This solvent plays an important role. Okay. If solvent is water, the solution is known as aqueous solution. For example, aqueous solution of NaOH. Aqueous solution of NaOH. Aqueous NaOH, if we are using to write, NaOH is solute and aqueous is what? That is solvent. So, if we having water as a solvent, that is known as aqueous solution. If we having water as a solvent, that is known as aqueous solution. That is known as aqueous solution. If water is not a solvent, then if water is not a solvent, that is known as non-aqueous solution. That is known as non-aqueous solution. For example, benzene in toluene. Benzene in toluene, because benzene and toluene both are the organic solvent. Is it clear? Solvent tell us about the state. State means whenever we have any solvent have any state, that is the state of solution. Second, if we have water as a solvent, that is considered as aqueous solution. What tell us about solute? Solute tell us about the concentration. Solute tell us about the concentration. What is concentration? Concentration, the amount of solute present in the solution. The amount of solution present in the amount of solute present in the solution means how much amount present in the solution. For example, 4 gram of NaOH in 1 liter of solution. This amount is known as concentration. This amount is known as concentration. Means whenever we know the amount of solute, they tell us about the concentration. In terms of concentration, we have two types earlier, dilute and concentrated. Dilute solution and concentrated solution. Dilute solution which contain less amount of solute. For example, 1 spoon sugar in 1 liter water. Yeah, we can say 1 gram sugar. 1 gram sugar in 1 liter. Concentrated solution. The solution which contain more amount, maximum amount of solute. For example, 42 gram of sugar in water. 42 gram of sugar in water. This is known as concentrated, this is known as dilute. But we are not taking these two consideration to calculate the concentration of any solution, because this is not a specific amount. So we calculate the concentration in different terms. For example, methods to calculate the concentration. Methods to calculate the concentration. First, methods to calculate concentration. First, mass by mass percentage. Second, volume by volume percentage. Third, mass by volume percentage. Fourth is ppm, part per million. Fifth is mole fraction. Sixth is molarity. Seventh is molarity. 8 is strength. We study one by one all these. First is mass by mass percent. Mass by mass percentage. As percentage is present here, in this case the total mass of solution is 100 gram. Total mass of solution is 100 gram. If I am saying I am having 10% NaCl solution, 10% NaCl solution in water. I am having 10% NaCl solution in water. It means 10% means mass of solute is 10 gram. Mass of solute is 10 gram. Mass of solvent is 90 gram, because the mass of solution is always how much? 100 gram. Is 100 gram. Is it clear? If I am saying we having 20 gram of NaOH dissolve in. If I dissolve 20 gram of NaOH in 80 gram of water, then what is the mass by mass percentage of solution? Mass by mass percentage of solution in terms of solute. In terms of solute. Mass of solute is 20 gram. Mass of solvent 80 gram. Mass of solution is 100 gram. From the given data, mass by mass percentage in solute is equal to mass of solute divided by total mass of solution multiplied by 100. This is the formula to calculate the mass by mass. That is equal to mass of solute is 20. Mass of solution is 20 plus 80 multiplied by 100. 20 upon 100 multiplied by 100. That is equal to 20%. That is equal to 20%. This is the method we can calculate the mass by mass percentage of the concentration. Next is volume by volume percentage. Okay, before this, can you tell me what is the meaning of 98% by 48% by mass of H2SO4 in water? Question. What is the meaning? What is the meaning of 48% by mass of H2SO4 in water? It means mass of solute is 48 gram. Mass of solvent, that is, what is the solvent? Water, is equal to 100 minus 48 to 52 there. And the mass of solution is 100. I think this is clear. Next is volume by volume percentage. Again the same thing. The amount of liquid in 100 ml of solution. The amount of solute liquid in 100 ml of solution. For example, 10% of HCl solution in water. It means 10 ml HCl dissolve in 90 ml of 10 ml of HCl dissolve in 90 ml of water. This is the meaning of 10% HCl. Next is the most important, that is mole friction. That is the mole friction. Mole friction. Before discussing mole friction, some notation we have to be learned. First notation. In a solution we have two components. First is solute and second is solvent. Whenever given mass of solvent is represented by WA. Molar mass of solvent represented by given mass of solute is represented by W. Molar mass of solute represented by MB. Number of moles of solvent represented by Na, and that is equal to given mass divided by molar mass. Okay. The number of moles of solute is equal to Nb is equal to Wb upon M. This is the notation. I am again repeating. The given mass of solvent is equal to the given mass of solvent is Wb. The molar mass of solvent is Ma. The given mass of solute is Wb. The molar mass mm is molar mass. This mm is molar mass. Clear? Molar mass Ma means A represent the solvent and B represent the solute. Okay. Given mass of solute is Wb. Molar mass of solute is Ma. The number of moles of solvent is Na, that is equal to Wa upon Mb. Number of moles of solute is Na, that is equal to Wb upon Mb. Next, the mole fraction. What is mole fraction? Mole fraction is represented by X. Okay. So the mole fraction of solvent is equal to Xa. Mole fraction of solute is equal to Xb. Xa is the mole fraction of solvent, Xb the mole fraction of solute. So now what is mole fraction? What is the mole fraction? The ratio of number of moles of one component to the number of moles of the solution. For example, Xa is the mole fraction of solvent, that is equal to Na upon Na plus Mb. Next, XB is equal to NB upon NA plus NB. This is the mole fraction of, this is the solvent mole fraction and this is the mole fraction of solute. Let's start with mole fraction. Mole fraction. Mole fraction is defined as the ratio of number of moles of one component of solution to the total number of moles of solution. Total number of moles of solution. In the last video we understood about the number of moles, representation of number of moles, representation of given mass, representation of molar mass, and also we studied about the notation of mole fraction, XA. XA is the mole fraction of solvent. Mole fraction of solvent, that is represented as Na upon Na plus Nb. Na plus Nb, as Xb is mole fraction of solute. Mole fraction of solute, that is equal to Nb upon Na plus Nb. Na is the number of moles of solvent, and Nb is the number of moles of solute, and this is known as the total number of moles of solution, because a solution contains solute and solvent. This is most important term, that is the mole fraction, and this is the physical quantity which do not have unit. The physical property, the physical quantity do not have unit. Means we can say this is a unitless quantity. Let's start in a numerical. Find out the mole fraction. The question is, find out mole fraction of 4 gram of NaOH in 100 gram of water. Mole fraction of 4 gram of NaOH in 100 gram of water. As we know, to finding the number of mole fraction, as finding the mole fraction of solute or solvent, we have in the formula XA is equal to Na upon Na plus Nb. XB is equal to Nb upon Na plus Nb. Okay, the most important thing, if we have the binary solution, binary solution means one solute plus one solvent. That is known as binary solution. Example: sugar in water. Okay. Next, if we having two solute, but the solvent always remains one plus one solvent, the total component becomes 3, and this is known as tertiary solution. For example, salt and sugar in water. This is a tertiary solution. If we having the binary solution, if we have binary solution XA plus XB, means mole fraction of solute and mole fraction of solvent is equal to 1. If we have tertiary solution, then XA plus XB plus XC is equal to 1. Is it clear? Okay. In this question we have to find out XA and XB. Okay, we start with XB. I am just removing all these things. Okay. To finding XA and XB, first we have to NA and NB. NA is equal to WA upon MA. NB is equal to WB upon M. Is it clear? WA, that is the given mass of solvent, and WB is the given mass of solute. We have in WA, that is 100 gram. MA, everyone knows that 18 gram per mole. Water having the molecular mass 18 gram per mole. Okay. WB is equal to 4 gram. MB is equal to 40 gram per mole. So, from this data, the Na is equal to 100 by 80. That is equal to 5.5 mole. 5.5 mole. Okay, NB is equal to 4 by 40 moles. 4 by 40 moles. That is equal to 0.1 mole. 0.1 mole. Okay. Now we have to find out XA. XA is equal to Na upon Na plus Nb. Na is equal to 5.5 upon. What is the value of Na is 5.5 plus 0.1. That becomes equal to 5.5 upon 5.6. This value is approximate 0.9. 0.9. This is approximate 0.9. 0.09. 0.0. Sorry, this is 0.9. 0.9. XA is equal to 0.9. Then what is the value of XB? XB is equal to 1 minus XA. That is equal to 1 minus 0.9. That is equal to 0.9. I am again repeating the question. You have to find out the mole fraction of NaOH, mole fraction of 4 gram of NaOH in 100 gram of water. I have to find out the mole fraction of solute. To find the mole fraction of solute, first we have to be clear about the formulas. XA is equal to Na upon Na plus Nb, and XB is equal to Na upon Na plus Nb. Na, first we have to find out Na and Nb. Na is equal to Wa upon Ma. Mb is Wb upon Mb. Wa is given 100 gram, Ma is 18 gram per mole, then the number of moles is 5.5 moles. Then Wb is 4 gram, Mb is 40 gram, Nb is 4 by 40 moles, then Nb is 0.1 mole. So we can calculate the value of XA. XA is the mole fraction. XA is the mole fraction of solvent, that is equal to the number of moles divided by the total number of moles of solution. 5.5 divided by 5.5 plus 0.1. Then it becomes 5.5 divided by 5.6. It becomes, okay, XA is equal to NB upon Na plus Nb. The value of Na is 5.5 divided by 5.5 plus 0.1. That becomes 5.5 divided by 5.6. And the value becomes equal to 0.9. This is the mole fraction of XA. Mole fraction of XA means the mole fraction of solvent. As we know this is a binary solution. Binary solution. Binary solution means XA plus XB is equal to 1. We calculated XA. The XA is equal to 0.9. So XB equal to 1 minus XA. So XB is equal to 1 minus 0.9. The XB value becomes is equal to 0.1 mole. To calculate the mole fraction of any component, we have in the formula Na upon Na plus Nb. By this we can calculate the mole fraction of solvent. Mole fraction of solvent becomes equal to 0.9. If we calculate the mole fraction of solvent, as we know this is a binary solution, then XA plus XB is equal to 1. If XA plus XB is 1, then we can calculate XB. XB is equal to 1 minus XA. The value of XA is 0.9. The XB is equal to 0.1. This is the method to calculate the mole fraction of any solution. The next topic we start with the molarity. The very important topic is molarity. Next is Molarity. Molarity is also a term to calculate the concentration of solution in terms of number of moles. In terms of number of moles, the molarity is defined as defined as the number of moles of solute dissolved in 1 liter of solution, dissolving dissolved in 1 liter of solution. Molarity is defined as the number of moles of solute dissolved in 1 liter. It is represented by capital M. Its unit is mole per liter and also written as molar. It is represented by capital M. So M is equal to number of moles of solute divided by volume of solution in liter. Okay. M can be written as NB divided by volume of solution in liter. So the unit of number of moles is mole and unit of volume is liter. So it becomes mole per liter and it is also known as molar. Next, we do a numerical regarding this molarity. Calculate molarity of a solution formed by dissolving 4 gram of NaOH in 1000 ml of water. We have to calculate the molarity of a solution which is formed by dissolving 4 gram of NaOH in 1000 ml of water. So answer, molarity is number of moles of solute divided by the volume of solution in liter. First we have to calculate NB. NB is the number of moles of solute, that is equal to WB upon MB. So what is the value of WB? That is 4 gram. And the value of MB is 4 gram per mole. So NB, the number of moles, is equal to 4 by 14. 4 gram divided by 4 gram per mole. And this becomes equal to 0.1 mole. Is it clear? Next is volume of solution. The volume of solution is given in 1000 ml. As we know that 1000 ml is equal to 1 liter. By putting the values in this formula, that is becomes equal to MB is equal to 0.1 mole divided by 1 liter. It becomes 0.1 mole per liter, and this is also known as molar. This quantity. So it becomes 0.1 molar. This is the method to calculate the concentration in terms of number of moles. Next, we move towards the molarity. Molarity is defined as same in terms of whenever we are taking this volume, that time we calculate the molarity. If we have molarity defined as the number of moles of solute dissolved, the number of moles of solute dissolved in per kg of solvent, Molarity क्या चीज होती है? The number of moles of solute dissolved in per kg of solvent. It is represented by small m. It is represented by small m. Its unit is mole per kg. Mole per kg. So m, and it is also known as molar. Molarity is also known as molar. Molarity is known as molar. So small m is equal to number of moles of solute. Number of moles of solute present in per kg of solvent. Per kg of solvent. Number of moles having unit mole and per kg having unit kilogram. So it becomes mole per kg, and this is also known as molar. It is also known as. So we have to calculate. If I am saying calculate the molarity of a solution formed by dissolving 4 gram of NaOH in 4 gram of NaOH in 1000 gram of water. Then what is the molarity? The molarity, as we know, the molarity is defined as the number of moles. Molarity is equal to number of moles of solute. Number of moles of solute present per kg of solvent. Okay. How can we calculate the number of moles of solute? Nb. Everyone knows that Nb is equal to Wb upon Mb. What is Wb? Wb is the given mass. Mb is the Wb is given mass, and Mb is the molar mass. Okay. What is Wb? Wb is 4 gram. Mb is, everyone knows that 40 gram per mole. Then Nb is equal to 4 upon 40. This is gram per mole and this is gram. Gram to gram cancel out. 1 by 10. It becomes 0.1 mole. Okay. Then molarity is equal to, okay, mass of solvent is 1000 gram, and this 1000 gram can be written as 1 kilogram. So the molarity is equal to number of moles, that is 0.1 mole, and per kg of solvent we have 1 kg of solvent. This becomes 0.1 mole per kg. Is any doubt? Molarity and molarity are the two terms which help us to calculate the concentration. Molarity, the number of moles of solute dissolved per kg of solvent. It is represented by small m. Its unit is mole per kg. It also known as molar. M is equal to the number of moles of solute per kg of solvent. The number of moles represented in moles and the mass of solvent represented in kg. The unit becomes mole per kg. There is a numerical. Calculate the molarity of a solution formed by dissolving 4 gram of NaOH in 1000 gram of water. So molarity is equal to number of moles of solute per kg of solvent. How we can calculate the number of moles? Number of moles is equal to Wb. Wb is known as the given mass. Mb is known as the molar mass. Given mass is 4 kg. Molar mass is 40 gram per mole. The Nb is equal to 4 by 40. It becomes 0.1 mole. Mass of solvent we have given 1000 gram. That can be converted into 1 kg. So molarity is equal to 0.1 mole divided by 1 kg, and its become is equal to 0.1 mole per kg. Calculate molarity of 68% of HNO3 solution in water. Calculate molarity of 68% of HNO3 solution in water having density 1.403 gram per milliliter. Okay. First, to understand the question is saying that calculate the molarity. First, we just write down the definition. Molarity is number of moles of solute present in per unit volume in liter. Per unit volume in liter. Okay. NB can be calculated as WB upon MB. Okay. In this question, we have given 68% by mass of HNO3. 68% by mass HNO3 means WB is 68 gram. Mass by mass percentage. Mass by mass percentage tell us about if we having any solution percentage in percentage. If any solution concentration present in percentage, this particular percentage give you the mass of solute. Okay. WA is 100 minus 32, that is equal to 8, and it becomes equal to sorry. This is 68 2 and 32 gram. We having WB is 32 gram. 32 gram because we have the total mass of solution is 100 gram, that is 32 gram. Okay. Then MB is equal to we having HNO3. HNO3 having mass. Hydrogen having 1, nitrogen having 14, each oxygen having 16. Then we having 13 oxygen, 3 oxygen, that is 48. 8 or 4, 12 or 1, 13, 1. 4, 5 and 1, 6 gram. Is it clear? We having the molecular mass 63 gram per mole. 63 gram per mole. Is it clear? Is it clear or not? This is the MB. MB is 63 gram per mole. WB is 68. So we have to calculate NB. NB is equal to given mass, that is 68 divided by 63. It becomes is equal to 68 divided by 63. Please calculate कीजिए आप. It becomes is equal to 1.07 moles. I am again repeating. Molarity is number of moles per unit volume. Okay. According to the question, we having 68% of HNO3 solution. Okay. If we have 68%, that means mass of solute is 68 gram. Then molar mass of the solute is 63 gram per mole. We can calculate by these two the number of moles. NB is equal to 68 by 63, that is equal to 1.07 mole. Means this solution contains this much mole of HNO3. Next we have required, what we require? Volume. Because whenever we have to calculate the molarity, we require volume. But we have given density. Density is 1.43 gram per milliliter. Can we calculate the volume? As we know that density is equal to mass per unit volume. Density is mass per unit volume. If we want to calculate volume, that is mass per density, then how can we find out the mass? Where is the mass of the solution? Mass of the solution is present 68%. 68% means the mass of solution is 100 gram. As I told you earlier that mass of the solution is 100 gram always whenever the mass given in percentage. Okay, the volume becomes is equal to 100 by 1.403 milliliter. Calculate कीजिए how much amount comes. It becomes is equal to 712 ml. It becomes 71.2 ml. This is the volume in milliliter. This is the volume in milliliter. But according to the formula, we require the volume in liters. What will happen? Then 712 divided by 1000. This become liter. This become liter. Then molarity is equal to NP divided by volume in liter. NP is equal to 1.07 mole and the volume is 7.12 divided by 1000, then goes to liter. And this is liter. If we want to remove the point, this point is removed, there is 10. This point is removed, there is 100. 1, this is cancelled out. 1070 divided by 712, that is mole per liter. Try to calculate this. It becomes is equal to, this becomes equal to 1.5 mole per liter. Okay. I think understand this. I am repeating this again. We have to be given that 68% of HNO3 in water. Please clear this point. 68% HNO3 solution in water. 68% means total amount of solution is 100. Total amount of solution is 100. Mass of solute is how much? 68 and solvent is 32. Please clear one thing, whenever the mass is given in percentage, so calculate that this percentage is the mass of solute and the total mass of solution is always 100. 100 minus mass of solute gives you the mass of solvent. Is it clear? Okay. The molarity is equal to number of moles per unit volume. NB is equal to WB by MB. We can calculate NB is equal to 1.07 mole. To calculate the volume, we have only density. As we know that density is equal to mass per unit volume. Volume is equal to mass per unit density. Volume becomes equal to 71.2 milliliter. But we require the volume in liters. So that is divided by the 1000. It becomes is equal to 71.2 divided by 1000. It becomes in liter. So we calculate the molarity, that becomes 1.5 mole per liter. This is the method to calculate the molarity whenever the density is given. We do not have direct values of volume and number of moles. If I am taking the same question, having the density, and I am changing one thing. Calculate the molarity. Calculate the molarity. How can you calculate the molarity? Okay. As we know, molarity is equal to, what is molarity? Number of moles of solute. Number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. Clear? WB we have calculated, that is 1.07. How we calculated? NB is equal to WB by NB. WB is 68, MB is 63. That NB is equal to 68 divided by 63. That is 1.07 mole. Okay. Now we require the mass of solvent in kg. So we have no need to convert the density into the volume. We having again the same thing. The total mass of solution is 100. Mass of solute is 68. Mass of solvent is 62 gram. The mass of solvent is equal to 32 gram. How can we convert this into kilograms? 32 divided by 1000. This is kilogram. Clear? Then molarity M is equal to M is 1.07 divided by 32,000. To remove the point, 100 cancel out divided by 32. calculate the molarity, that is it becomes is equal to 33.2 mole per kg. So we can calculate the molarity as well as molarity if the solution concentration, solute amount is given in percentage or we have given the density. Clear? Okay. I think there is no any doubt regarding the molarity, mole fraction or mass by mass, volume by volume percentage. Next topic is percentage composition.